if we look for more when it comes to error handling, I don't think many people here use exceptions in their game engines or anything. No? But when you get out in the real world, people are using exceptions all the time. And it's maddening. Because what an exception is it's saying this function can throw and just jump to another random location. And there's no like specification that says when it's going to do it or where it's going to do it. So here what happens with Go is you can ignore errors. But if you try and take one or something like that, one of the values, you have to take all of the values. So this line right here is going to throw an error because this function that returns an error, isn't getting that handled. So it's going to say multi-valued function treated as a single value. Another thing to explain is that Go, you can return multiple values. So here I'm returning an int and an error. And what I'm doing here is I'm saying I'm ignoring the int part of that and just looking at the error. So error handling becomes a lot easier because you can see right away when you handle an error. And if you don't handle an error, the compiler says, hey, you messed up. And it tells you. The difference with C++ now is that a function can say it doesn't throw and still throw. A function can say it throws and not throw. A function cannot say anything. And there's no way of knowing unless you just go and search and look through the code yourself. So at scale, that becomes a problem. Even when you're dealing with 4 or 5 people on a game team, it becomes hard to know what every piece of code in a game engine does, right? Are there any questions so far?
Actually, on the first slide of Go example code, there was an ampersand next to an object.
Oh, thank you. Yeah, that means take the address. So give me a pointer to the object. Mm-hmm. So what happens here is this is like saying a new object. And this is just the object itself. It's not a pointer to it or anything. Address says, give me the pointer. So all the code examples, thanks, by the way. All the code examples are going to be correlations to C++. So it's going to be the Go version of the C++ code. Yep.
Is it possible to explicitly state what you want the type to be instead of letting Go figure out what the type is?
Yeah. Let's see here. I could say var foo equals a foo, like that. It's kind of like auto in C++ though, or has anyone used auto? So it's just like that without having the auto keyword. And that's what I like about Go. It does everything C++ is trying to do, like and trying to move towards, but just without all the crust from C98 and before. So I actually really like C++ 14 and 17. It's just hard to get someone that knows the same dialect of C++. Okay. So the same thing again. In C++ and C, you have this concept of void pointers. Pointers that can be anything. They just point to arbitrary data in memory. And you can do things with them, like reinterpret, cast them into whatever you want to. And the compiler won't yell at you and won't tell you that that's not that type or that is that type. It's kind of up to the programmer to reason about it. The thing is, a compiler is really, really smart. And it's a lot smarter than a human is in some regards. And it's a lot faster than a human is. It can find errors a lot faster. So here what happens, I have a function foo that takes Go's version of a void pointer, just an empty interface. And what happens is it's going to switch and do a type switch on here and say, inside of the switch statement, if you're an int, if you're a string, or if you're anything else, do these things. And it can tell all the way what type it is. That's something in C you can't do. You'd have to do some kind of crazy template compiler magic. You'd have to use a dynamic cast and have a virtual base type or some RTTI information. It becomes really complicated. And I'm not even 100% sure that this works with static cast. On top of that, in C, there's 5 different casts that I know of, and maybe there's more now. Sounds right? Okay, good. In Go, there's 1. But it's just as powerful. And then when it comes to deploying things with different architectures, does anyone code on a Mac and Windows? No? Yeah? There we go. I like you. In a lot of C++ code, you'll see if-defs. If define this, do that. If define a test program, do this. And it gets really, really ugly really fast. What happens is you have code that's in your file that's not executable. And how do you know the difference without reasoning about it or having some like Visual Studio tell you? Go's solution to that is they take a file, some file, and then they have a build rule after it. It could be x86. It could be underscore test, which I'll show you guys a little bit later, or x64, and then only that code gets compiled. So when you look at the code for that architecture, it all gets compiled. There's no reasoning about if it's this or if it's that. So Go's aim is to simplify programming. Yeah.
The two different files. That means you'll have lots of, like, your code's gonna be really similar, but you have just a couple of lines that need to be different. Doesn't mean you're gonna have a lot of code duplication between these two files.
Oh, no. So a big difference with Go is that it works with packages. So how do I describe packages? So packages would be kind of like a directory. And anything inside that directory, I'll actually show an example. Okay. Here we have kind of a game engine I wrote, or part of it. And I have this package kernel. And what's interesting is anything in here, you'll see if I open any random file, it says package kernel. Package kernel. Anything in there, it's like being in a namespace in C++. They're all together. They're all related. So what that means is you can share code among different files and only put the parts that are different in the architecture-specific ones. Does that make sense? Okay, and I'll show more examples of that in a little bit too. Okay. So now enums. Does anyone? Yeah, everyone's used enums in C. Have you ever noticed how the name leaks out anywhere you go? That's a problem because you can't encapsulate what you're doing. You can try and get around it, but Go solves that with its packages. So now I have a package, and it's kind of the question you're asking. And inside a package foo, I define Go's version of enums. So I have a const. I have this construct iota, which kind of just counts. So this one is 0 plus 1. Then this one would be 2. This one would be 3. 0 plus 1, yes. Okay. And then I have a package main. Package mains are what execute. They're like your drivers. All of them have a function main, just like C++ has a void or int main. And then when I run that, you see that I have foo bar, and I have to preface it foo bar. So it's enclosed in that space. If I were to try this, it says you can't refer to unexported name. And what that means is anything lowercase is going to stay inside of the package foo. So it's kind of hidden. Why is that important? Because in cases like this with C++, you might have an enum where you have days of the week, and you say max days of the week, or last days of the week. Or here we're saying last foo. And that's really just for you to count. You might declare arrays that are that size or something like that. But you don't ever want anyone to have to declare or use that somewhere and pass it into you, and you don't have to check for it. In C++, you can't get around it. This is going to be visible. And what's worse is the things inside of enum bar or enum foo are visible everywhere too, and can just be described as bar, baz. And that's why people do these things like put little prefixes on their enums. So in C++, you can get around that by wrapping it in a namespace. And that's a little bit better. But still, like last foo is still visible, and you can't really get around that. And there's this new thing in C++ 11 or 14, I'm not sure which, called enum class, which does the same thing as that, just a little bit cleaner. But even then, you can still see the control variables that you want to keep hidden. And this technique is another one I learned just by looking through the open source code. It's really interesting. It's another case of like, I'm looking at what these smart people who wrote this language did, and I'm learning from it. Like, oh, it makes sense to hide these things. And they don't have to write code now to like care about errors that happen because people pass in these control variables. Again, switches are another one. So Go is interesting because you can have if statements and switches where you have an expression first, and it's captured there, and then you can use the variable from that expression. Is that clear? So here what I'm doing is in this switch, I'm declaring a new variable x. And what it is a random int between 0 and 3. Really quick, because I never explained this, I'm sorry about that, is the import is saying like what packages you're using. So everything is bound by its package. So funct is the formatting package. Math random is where I get like random from, wherever that is. Oh, here. And time is where you get timekeeping packages. Yes. Mm-hmm. Yep, it'll go and it'll download them from URLs and things like that. And the reason why they did that is because code sharing is a software engineering thing. It's just a really, really smart language. But that's all local stuff that I wrote, and then it downloads it locally to your machine, so you don't have to have an internet connection or anything like that. Yep. Yep. And I'm going to talk a lot about closures and threading later. Okay. So here we have this switch statement, and I've highlighted a couple lines. First off, we have a for loop. You can have for range, which is a lot like for each in C++ 11, 14. We have a switch. Now, switch can act on arbitrary expressions. So it could have 0, 1. It could be a string there. It could be a few other constructs there. And then default, just like regular C++ default. But the thing is, there's no automatic fall through, so I don't have to say break. That should be the default behavior. That's what most programmers want to do most of the time. You can say fall through, I think it is a keyword, if you want to fall through, and you specify, I want this behavior. And now what's going to happen is I'm going to get a random number every once in a while, and then let me close this down. And then I get defaults. But there was no fall through ever. If we did the same thing in C, I have some random generator. I have to declare y a lot higher because it can't be captured here and it can't be declared here. And I'm getting fall through. So the default behavior in C++ is bad for programmers. You have to remember a lot of little rules to be good at it. You can make it a little bit better by adding braces on the cases, but now you're still falling through. So that's at least two things you have to remember. Here it actually works because we put in the breaks. Or C++ decided to add another keyword to do the same thing. And that seems to be the C++ approach to things, is add more to remember. And Go's approach is try and remember less, so you can actually focus on the problems you're trying to solve. Same thing happens with arrays. So here is a function that takes an array of 3 integers. You can declare things on the same line. So here I have A3, which is an array of 3 ints, A4, an array of 4 ints. This is going to error because the type of A3 and A4 are different types. In C++, they're not, and that causes a lot of problems. This is going to error because A3, if you access from 0, this is out of range. So it tells you, hey, you went too far, and that's a common problem in C++. And then also passing A4 into a function that takes an int of 3 doesn't work. And you see the compiler tells you all those problems. And then if I run it again, and then I use a variable that I didn't need, but all right, now we have a working example, or not. All right. Okay. I'm happy. The same thing had happened in C++, except all of those are legal. And that's what's scary about C++. You have to be really, really, really smart to be good at it. I'm not saying you guys aren't smart. Same thing for division by 0. In Go, if you divide by 0, that causes an error. The compiler can tell you. And then what you can do is you can specify, I want to use a math type where divide by 0 is legal. Mm-hmm?
How white space dependent is this?
Oh, it's not. So Go formats all for you. I'll show you that in a second. So this last thing in C, this is just undefined behavior. And undefined is the worst thing that happened in a programming language because you don't know what's going to happen. You don't know when it's going to crash or why it's going to crash. Same thing for, yeah?
What's the difference between the colon equals and this equals?
Colon equals says infer the type. So it's like auto in C++. And equals you says that either this already exists or you had to make the space for it before. Another issue with C++ is that there's implicit conversions between things. So a pointer can become a bool can become an int can become a bool, vice versa. In Go, that doesn't happen. So here I get an error because I use a non-bool type. And I have to just make a Boolean expression. Same thing here. In C++, these are all legal. And this is what makes writing classes and containers so hard for C++. Because you don't know what you actually have. You have to explicitly check for things. Okay, so that was a lot of information in a row, like a lot. Are there any questions about that? Okay. If there are,